This part, we just have to switch these two steps together. So just gonna move them around. So we have the load in the initial situation, and then in the final situation we are removing the load, and in this case there's gonna be swelling because we're removing the load, and the clay layer is gonna expand, and we want to know how much expansion is gonna happen. So we're gonna do the same procedure. The values are exactly the same. We only need to switch the columns together. So just gonna copy these. And then these two columns. Okay, so again, in the initial situation, we have the load on top of the layer. In the final situation, the load is removed. So this sigma prime 0 is for when we have the load, and this sigma prime 1 is for when the load is removed. And the values are calculated in the same way that we explained in the previous part, and the corresponding void ratios are going to be determined in the same using the same method, using the graph. And the only thing that we're going to change is these two columns. So this is going to be negative 0, 1, 0, 3, negative 0, 0, 0, 0, sorry, 1, 1, negative 0, 0, 0, 9, negative 0, 0, 8, and we are going to use the same equation for SC. So it's negative 12, negative 10, negative 9, negative 7, and the total would be negative 38 millimeters. And the negative sign is an indicator of swelling. So if I summarize everything, we had this 2-layer of sand and clay. Then we put this load on top of it. And then again the load was removed. So we had 318 millimeters reduction in depth, and here we had 38 millimeters increase in the depth. So overall we had 318 minus 38 millimeters, which is equal to 280. Millimeters reduction in our source.